Hi, welcome to my video on defining an algebraic term, a constant term, and like and unlike terms. Defining a term. A term in algebra is defined as a single expression which has one or more variables and or numbers. Notice it has only one. There's no addition or subtraction between any of these. So we got a number, 7a, negative 3xy, b cubed, 2n squared, negative 9abc. Notice there's only one. There's no addition or subtraction. A term has no addition or subtraction signs. So, not a term. These are terms, one term. Not a term. Notice x plus 8, 1, 2. Y minus x, 2 terms. 3x plus y minus 1 has 3 terms. These are expressions, but they're not a term. Everything we write down is an expression. But again, one term, no addition or subtractions, just one term. A term consists of 2 parts. So we have a term, we have a number of, and we have a variable. So if a term will have a number and or variables. So if a term has a number, we call it the numerical coefficient. If a term has a variable, we call it the literal coefficient. Numerical for number, literal for a variable. Examples: 4x, the numerical coefficient is 4, and the literal coefficient is x. 6ab, the number is negative 6. The other part, ab, is the literal. A half y, the number is a half. Y is the literal coefficient. Negative 11 x squared y, negative 11 is your numerical coefficient. X squared y is your literal coefficient. The literal is the letters and numerical is the number. Practice. Pause the video and work out the answers to these and play it back. And 9 is the numerical. C cubed d squared is the literal. 8 is the numerical. X to the 5th is the literal. Negative 13xyv, negative 13 is my number, and x, y, v. And we just want to put another one in there. Just add number 4 and go x. So notice if I got an x, it's understood to be 1x. So the literal coefficient, the numerical coefficient is 1, and the literal coefficient is x. So when you have an x, there's understood to be a 1 in front of it. Again, numerical 1, literal x. Let's continue. Now, we have a term which we call constant. Constant term has a numerical coefficient and no literal coefficient. A constant term is a number, like 4, or negative 6, or a half, or 1.4, or square root of 2, or pi, which we know approximately 3.14, but it's a number. There's no variables in these. So a constant term is just a number with no variables, no literal coefficients. Practice. Which ones are the constant terms? Yes, 7. Fraction, yes. Negative 6, yes. Root 6, yes. Notice the rest have variables. Notice x, y squared, ab, x, y, d. So these are not constant terms. So the constant term is just a number. What about a zero exponent? Remember we reviewed when we did I did a section on exponents, exponential rules, and one of the rules we talked about was 0. So let's bring that back again. And the rule is that b to the 0 equals 1, where remember b is not allowed to be 0, the base. So 4 to the 0 is 1. Negative a half, negative 2 to the 0 is 1. 1/3 is 1. Notice now we have a double here. So we have a negative of negative 9 to the 0 is 1. So that's negative 1. Remember, watch to the 0 power is 1 except 0. So we have to work out the power first to get 1. A to the 0 is 1. x to the 0 is 1. Y to the 0 is 1. Notice, provided a is not 0, provided x is not 0, provided y is not 0. 4, b to the 0. You notice that the 0 exponent is on the b, so that's a 4, bracket 1. So that gives me a 4. Notice the 0 is with the c, not with the negative. So it's a negative 3, bracket 1, which is negative 3. Now you notice 4y is to the 0 power. So that's a 1, provided y is not 0. 7x to the 0. Notice again, the x is to the 0, not the 7. Notice this c is to the 0, and that's a 1. So you get a 6. So notice when it's raised to the 0 power, you get a 1. But be careful. If, another example of that would be if I had x, y, v, and I raised that to the 0 power. So that's, notice the x has a 1 power. So that's x times 1, which is x. So just emphasizing, if it's to the 0 power, notice if it's in a bracket or not. So it's not in a bracket, so it's only the c. Be careful. But I'm going to use that to explain about the constant term. And we have a chart here, a little table. Constant term, a product of the constant term in 1, and we have expressed 1 in terms of x. So we have a constant term of 4. So 4 is 4 times 1. And so that's, in terms of x, that's 4x to the 0. So 1 is x to the 0. Negative 3 is negative 3 times 1. And what's another name for 1? X to the 0. Note, it's only the x. 1 is x to the 0. 1 is x to the 0. So 4 times x to the 0 is 4x to the 0. 7. 7 times 1, which is 7x to the 0. Negative 9 times 1. And what's 1? X to the 0. A half times 1, which is a half x to the 0. It's surprising when I taught students in the later grades that they didn't know about the 0 power. So I said, well, you gotta know it comes into play in making things okay. Why things, the algebra works out the way it does. Note, any constant term can be expressed as a term with a 0 exponent of the variable. So any constant term, no matter what it is, it could be x to the, like 4. Let's go with 4. 4 is 4x to the 0. And we got a negative 8. So that could be negative 8x to the 0. Very important to know that. It'll help you understand. Remember, the thing about my YouTube channel is math fully explained. Makes sense. Let's talk about some what we call like terms in algebra. Like terms in algebra have the same numerical coefficient. They have the same numerical, that is, they have the same variables with the same exponents of each variable. So they have to have the same variable. So notice in A, you have an x, an x, an x. And it makes no difference what the numbers in front are, but you have to have the same variable with the same exponent. And the exponent here is 1, 1, 1, understood. Notice in B, they all have x squared, so they're like terms. So x squared, x squared, x squared. So the literal coefficient here is x, or you could call it x to the 1 if you want, the same thing. And the literal coefficient here is x squared. And right here, the literal coefficient, the numerical is 4, negative 6.5, and the literal coefficient is the variable. So notice ABC, ABC, ABC. So they got to have the same variable and the same exponent. Let's illustrate that as we go. Practice. Place the like term in the blank to the given term. So here's your given term, 6a. So which term over here is like 6a? It has to have an a. No, no. Oh, there it is. Negative 2a. Same variables, same exponents. Negative 7xy, I have to have an xy. Nope, that's an x squared. That's a y squared. That's xyc. Nope, so it's there, xy. And what number's in front of this? Understood to be a 1. So that got an xy, that has an xy. So like 2x cubed, it has to have an x cubed. Nope, that's x squared. That's x to the 1. Oh, there it is, 6x cubed. That's x to the 4th. No. So x cubed, x cubed. This term got an ac squared. Sorry, a bc squared. So find a bc squared. Power of b is 1. No, b got a 2. C got a 3. No. B got a 1. And D got a 4. Nope. Oh, bc squared. The numerical coefficient right here is negative 5. And the numerical coefficient here is 1. But as long as they got the same variables and the same exponents. And let's see, we have to have an x to the 4th, y squared, w. X to the 4th, nope. Yes, y squared, w. There it is, negative x to the 4th, y squared, w. Remember, the x has to have a 4, the y has to have a 2, and the w got a 1. And there's the 1 right there, and there's the 1. But it has to have the same variables and the same exponents. A squared, b cubed. I'm looking for an a squared. Nope. Nope. Yes. And then when I get the a squared, I'm looking for the b cubed. Ah, there it is right there. So it's 7a squared b cubed. That's a negative 1 understood. Notice this is a negative there. There's a 1 understood. And this one we have to have a y to the 5. 3, nope. 4, nope. 3/4, nope. And there's a y to the 5. But the exponent, the coefficient in front is a 1. So like terms have to have the same variables and the same exponents of those variables. Let's continue. Now, what about unlike terms? Unlike terms in algebra have different literal coefficients. They could have different variables, or they could have the same variables with different exponents. So if you got different variables, they're automatically not alike. But if they got the same variable, then you got to check the exponent. So some examples I'm going to write in could be a, y, and x, b. Notice they have different variables. Or you could have a 2x and a 3x squared. So they got the same variable but different exponents because that's a 1. Or you could have negative 4abc and you could have a 7ab. Notice they're different variables. So if you have the same exponents, don't make any difference. So you got x cubed and you got an x4. Notice if I put an a on that, they're still different. So a, x cubed, x to the 4th, they have, again, these are not like because they got different variables. But if you had the same variable, you got to have the same exponent. So they're not alike. Practice. Place the unlike term in the blank. So of all of these terms here, which one is not alike? So I got an xy, an xy, and an xy. So the unlike term is negative x because it doesn't have a y. Number 2, I got an x squared, an x squared, an x squared, and an x. So the unlike term is 8x. And we got an a. So we got an a, all of them got an a. All of them got a c. But I got a p to the 1 power. So that's alike. A, that's a 1, 1, they're all 1s. And that's p squared. So 6ac p squared is unlike. So all, that's, again, I put these 1s in. That's 3 of these are the same because it's ACP. ACP. Same variables, same exponents. Number 4. we have an x squared, x. So we got an x, and an x. The unlike term is x squared because it has a different exponent. Number 5, x squared y cubed. I'm looking for an x squared, right there, and a y cubed. X squared, y cubed. 3 of these are the same, so x cubed, y squared is different. Notice the x here has got a square, the x here has got a cube, and the y is different too. Number 7, I got x cubed, and x cubed. So the different term is 3x to the 4th. And if I have a to the 4th b, a to the 4th b, so a has to have a 4th power. So that's a to the 1b to the 4th. That's a 4b, right? A 4b, so that one, and that one are like terms. So the unlike term is a half a b to the 4th. And number 8, I have a y, and a y, and a y, so the unlike term is 8x. Notice I don't look at my numbers, I just look at my variables. So you have to have the same variable with the same exponent. Same variables, same exponent. Okay, here we go. Place the like terms in the blanks. So when I look to this, the like terms, so let's take the first one. I have a 4x, so let's write that right there. Is 8xy like that one? No, because it got a y. Is 3 like those two? No, so I'll put it over here. So as I start out from left to right, if I find one, write it down. If I find another one like it, write in the same blank. 2xy, where does it go? Well, it goes right there, because I got to have an xy. Negative x goes right there. 4x and negative x are like terms. And negative 7. So that's a constant term, because why? That's understood to be 3x to the 0. And that's a constant term. That's 3x to the 0. A constant term is a number. Okay, pause your video and see if you can fill in all these blanks with the correct answers. Do them all and then play it back to see if you're right. Here we go. I'm going to put AB here. And I'm going to put A squared there. And a B is different, it goes there. And 4A squared, oh, that's right there. And 6AB, negative 6AB goes there. And B cubed is there. So if you put a term in the blank, the other one that goes with that in this blank has to be like terms. Is there any more? So I use, see the reason I start here and go this way, because when I write that one down, he's gone. Then I put that one, he goes there. That one is different, so he goes there. Then as I work, then I fill them in. So when I did that one, I put it there. Then when I did that one, so now I used them all up. I didn't miss them. So when I write down my like terms here, I'll put the 8 here first. Is this one like it? Nope, so I'll put that one there. Is 9x like it? Nope, because I got a different variable. Now I have negative 7x squared, so now I can start. Yep. So notice I'm going from left to right. Negative 6. Ooh, it's a constant term. It's a number. It goes over here. X. It goes with the 9x. A half. That's a constant term, so it goes with the 8 and the negative 6. And a negative 3x goes with the x. So notice their numbers, their x squareds, and their x's, like terms. Number 3, negative 7. Okay, put that down. B is not like it, so let's put it in this blank. 2a, yeah, that's like that. So as I do them, 4a, oh, that one goes there. 3b goes with the b. And a negative 8, all by itself, because it's a number. So there's the a's, there's the b's, and there's the constant. Number 4, x, y squared w. So x, y squared w. So this one is x squared, a y, and a w. And this one got x squared, y squared. So this one, nope. Oh, this one, that one goes over here. So let's cross them out as we use them. 4x squared, y squared, w. Done. Now, what is I'm looking for an x squared, y, and a w. x squared, y, and a w right there. So that one goes in this blank. Now I'm looking for an x, y squared, w. And x, y squared, w is right here. So that's a 3. 3x, y squared, w. So we got them all used up. So notice like terms. Same variables, same exponent. And number 5, I got an x cubed. Then I got an x. Then I got a 7. They're all different. 4x goes with the x. So we're using them up. 2x cubed. Oh, there's the x cubed, so there's the 2x cubed. X squared, not there. That's an x. X cubed, constant. X squared got to go there. Negative 8 is a constant, so it goes with negative 7. So it goes with positive 7. And we got a negative 5x cubed. So that goes with the x, negative 5x squared, sorry. Notice my tongue is always getting twisted up with my brain. Anyway, you got the meaning. There's x cubed, there's x's, and I scratched them out as I went to indicate I got 1, 4, I got 8, 2, 4, 6, 8. Yep, I got them all. Here we go again. A to the x. A squared x is different. Ax squared is different again. Notice they're all different. That's the square. That's 1. That's a 1, and that's a square. So the 3 of these are different. 4x squared a. That goes with this one. 4a squared x. Negative 6ax goes over here. And a negative 9, I'm looking for that's the a x squared. Done. Number 7, here we go. Put the 10x there. Negative 9 is a constant, so that's different. The negative 2x squared is different, so the 3 of these are different. They're done. Where does the 6 go? It goes with the negative 9 because it's constant. There's no x. When I say no x, remember, it's understood to be what? Negative 9. When I say no x, pardon, just notice, no is 0, no x, x to the 0. Another way. What's a 6? 6x to the 0. When you look at this, you don't see an x. So that means the exponent is no. No x, 0 exponent. No. No, 0. No, 0. That's another little way of thinking about it. Negative 3x goes with the 10x. 6x squared goes with the negative 2x squared. 5x goes over here. And x squared goes with the x squareds. And again, repeat, that's a 1 understood. Don't forget, x squared is 1, x squared. Y is 1y. And just a reminder, a 6 is what? 6x to the 0. Or a 6 could be, if you have a different variable, 6y to the 0. Anyway, that takes us to the end of this video. Hope you enjoyed it, but it's very important to know like terms, unlike terms, etc., etc., and what a term is. If you like my video, click the like button, subscribe button, and notification bell. Write a comment if you wish. And visit my math website, mathfullyexplained.com, and there you get information in different sections, one on me, one on videos, and one on the section on content. This is the most important because here you'll see what units or topics I have online, the number of videos on each of those topics, and the black font is what's already online, and the red font is what I'll be doing in the near future. Thank you very much. Bye-bye.